Anyhow, can I just tetrahedron? While we're, I mean, or both of you, I don't know. Can I just ask you? I can't. I guess it must be really late at your places, respective places.
Yes.
But is there anything from previous Hangout that you would like to address that I can maybe clarify in some sense? Something that was not properly addressed
I
at the
mean,
time.
I don't know. I mean, I just don't feel like you guys were really.
But
I couldn't say you specifically, but I mean, I don't think anybody was really acknowledged as far as that the information supported what I was stating basically. And I feel like they're trying to just kind of just. I mean,
well, for me, I wouldn't expect you to try and defend statements made by somebody else.
No.
There was a couple of people in this hangout there earlier that made a couple of statements that I would have liked to have gone over a couple of things about what they had said, but I wouldn't propose the same thing to you because you didn't say that.
But
So
I could
wouldn't expect
probably.
you to.
If somebody coming from a scientific background is making a statement, I could probably clarify it at least. I mean, the other person would have to answer for it ultimately, but I could probably clarify or sort of bring it a bit further to explain what they probably meant. There's one thing that comes up all the time, and this is something that sort of our side should be more careful about. That is the fact that people ask, well, can you see what is evolution? And then people always mention the fact that evolution is defined as change in allele frequencies in populations. You recognize this statement, right? That often, and then you would say, or somebody else would say, well, that doesn't explain. I mean, and everybody says, well, I also believe that. Even a creationist believes that allele frequencies in populations change, right? Anybody
Yes,
would believe that,
I mean,
exactly.
that happens with, my wife and I and our daughter.
Yes.
My wife and I have different,
Yes.
sequence, and my daughter will have a change in hers plus the, what is it, 100 or so
Yes.
mutations that are passed on, right?
So that then allele frequencies have changed till the next generation. So that is a statement I would like to clarify a little bit. Then because then people counter argue that, well, this is not what we are sort of not believing. What we're not believing is like millions of years of evolution and sort of molecule to man evolution. And of course, pointing at allele frequencies between one changes in allele frequencies from one generation to the next is not an evidence that evolution has taken place from monkeys to men over millions of years. And I agree that is not. So I think many people from the evolutionary side, that they cannot. I mean, they should clarify that these are two different processes. Both can be classified as evolution. Okay, but the evidence we have from monkeys to men are different. We would not use the same. We would not point to everyday observations when trying to demonstrate that monkeys to men has happened, as in the simple observation that allele frequencies change over a generation. That and these should not be conflated. And I understand why you think that people from the evolutionary side try to confuse the issue. My point is that if we want to sort of discuss what evolution is, if we need a minimal definition of what evolution is, that is when the allele frequencies come in. If we want to see what is the minimum requirement to say that now evolution has happened, as opposed to just a change in an individual over a lifetime, for example, then the allele frequencies from one generation from the next is kind of like a minimum. Do you understand? That's sort of a minimum thing that we can define as evolution.
yeah, because you could define aging as evolution.
Yeah,
Right?
but that, exactly. But that would be within an individual. So somebody has thought about this, and okay, to say that we have real evolution happening, something has to take place from one generation to another, and that we can call the minimal definition of evolution. And then I agree with you. It gets very confusing then when somebody then says, well, this does not prove monkeys to men, right? And I agree, it doesn't. And it's very confusing when people use the fact of changes in allele frequencies as some kind of, well, evolution happens. Well, yes, but that is not the same as monkeys to men, and I agree. It is a totally different phenomenon. And I would not use this as an argument for the second, or one as an argument for the other.
For me, that point kind of butts heads up against the example that we have of the, so many of the species that are still around now exhibit more stasis. They didn't change, go through these huge evolutionary changes that other species seem to, and in some cases the same environmental conditions would have been present at the same time. So you're the idea that there's huge jumps in changes in some species, and then you've got others which exhibit very little or almost none. They're almost unchanged from what they were literally millions of years ago.
Yes.
According to the base timeline, right?
Mm-hmm. Yes.
Sharks, coelacanths.
Mm-hmm.
There's some minor differences in the arrangement, the size of fins and things like that, but they're still basically the same creatures. They're still a coelacanth.
Yeah.
So they didn't even go beyond that, that level of development. They didn't change into a different kind of fish, right?
No. Well, and exactly, and if I want to argue that things have happened or not happened over a long time, I can start the whole process of motivating my thinking here and now. But first I want to just establish that no, the what's happening here and now in terms of allele frequencies is not evidence that it's happened over millions of years. And then, okay, if you would like me to motivate why some animals change and some do not, I can just say that probably the coelacanth is probably better off as a coelacanth. Its fitness, its survival is better if it stays a coelacanth than if it would change under the present circumstances. Whereas some other animals or organisms would change a lot during the same time because their circumstances for some reason are different. For example, if I may take during the same time as the coelacanth has stayed the same, I don't think maybe not much has changed in its present conditions that would make it better off being something else. The coelacanths we know today, they seem to be fairly deep sea dwelling organisms. They live in conditions in these deep sea crevices or whatever in the ocean floor, as far as I know. I mean, outside of the ground, or no, sort of the shelves. You know what the continental shelves? Yeah.
Yes, they're both of the living species are both deep water or relatively deep water fish.
Yes.
And they inhabit caves that have very low water turnover within them.
Mm-hmm.
So they're adapted to, they have a metabolism that's slow, that doesn't require huge levels of oxygen. The only point that changes is at the fetal stage.
Yeah.
Which is why they have that pseudo lung organ in their body as at the fetal point.
Yeah, I mean,
and it atrophies as soon as they go beyond that.
And if, sort of, as far as I remember, we have a situation, say, before the, and I don't know, do you believe in millions of years at all? Yes or no? I mean,
I'm not saying that I believe it. I'm saying it could be that,
yeah, okay.
or it could be shorter.
Yeah, okay.
I don't know, and I'm not willing to say that I know for sure whether it was.
Yes. But if we think within the evolutionary paradigm, what we have is a situation where at some point we've had, I mean, coelacanths, the coelacanths living today were once just a part of a big group of fish that had these sort of fleshy fins that the coelacanths have, and why we think they also are the origin of all the tetrapods. I mean, that was we think. But at some point, maybe 70 million years ago, coelacanths, many kinds of relatives of the coelacanths were still around, as far as I know. And also on land, dinosaurs roamed, and most mammals were just sort of tiny rodent-like creatures, as far as I understand. Then something happened so that the dinosaurs died out, and most of the relatives of the coelacanths also disappeared at this time, or maybe they disappeared before, I don't know. But what happened was that on land, whole new ecological niches opened up at that time, because the dinosaurs all got wiped out, as far as we know, except for the birds, sort of, which would be then, they are still dinosaurs, etc. But all the big predatory dinosaurs disappeared, including, and all these sauropods, the big herbivores as well. And we think that there was a meteorite, hitting the Earth and so on, and changing things. That is at least one thing that is fairly well supported. So the reason, yeah, I mean, this is just the story, but my point is from,
exactly.
Yes, but if you accept this story, it gives a quite good explanation why suddenly things change among the mammals while the coelacanth stays basically the same, because in the case of mammals, suddenly there is something has constrained their evolution for a very long time, because the niches, the ecological potential niches that they could have occupied were already occupied. So mammals probably did best staying small rodent-like creatures, staying out of sight of the big dinosaurs. But once the big dinosaurs are gone, there's suddenly a new opening to evolve in a completely different direction. And within a few tens of millions of years, we have a lot of the same megafauna appearing among mammals that we previously had. I mean, the mammals never grew quite as big, but the really big mammal fauna comes rather soon after the dinosaurs disappear. We're talking, I think, 20 to 30 million years, and then you have basically recreated the same ecological system, but now there are mammals instead. So the reasons, I mean, from an evolutionary standpoint, the reasons why mammals suddenly experience huge changes while the coelacanths stay the same would be that the ecological niches on land have drastically changed suddenly, or the possibilities to evolve have changed, while the remaining coelacanth species do not have the same incentive to evolve. Okay, over to you. That would be if you want me to give an evolutionary explanation, that would be my explanation at the time. Okay?
Okay. I fully allow anybody to believe what they want to believe, and now I'm not trying to say belief as in
not faith.
Insult of any kind.
No, I know. Belief as in a just a statement that you accept something as true.
Exactly, right? Mm-hmm. That you accept that as a fact, right? And I fully agree. Everybody, that's their right to accept whatever points offered to them would be facts or not. So, and the fact that that is the mainstream, that's the one that's forwarded by the mainstream establishment. That it's the Big Bang, evolutionary, progression of life on Earth. That whole. So, I completely understand that. It's just especially when you come to the point where you're, we have found that a number of those small early mammalians are still alive today, and they are relatively unchanged from what their ancestral version was.
Yes.
The fossil versions.
Yes.
I forget what the name of it is. It's like a bushy-tailed rat. That they found a couple of them, and they thought they'd been extinct for millions of years.
Mm-hmm.
Same way it was when they found the coelacanths back in the 30s, right?
Yep.
They found some fish off the coast of Australia that they thought was extinct millions of years ago too.
Yep.
Oh yeah, there's a number of species that are being found that are, the extant version of previously thought to be extinct species, right? So.
Mm-hmm. But the point is not that all of them would suddenly change. I mean, for some species it would still pay off to stay as they were, because I mean all species are not everybody is rushing towards the new niche, if you understand what I mean. Even in these new niches there is competition happening, and for some it wouldn't then pay off to stay just as they were.
But I mean, how would you know that? To me, it just seems like you're just reasoning retroactively
yes.
to function within a paradigm. And I understand the context.
Yes.
This is basically how you explain it, so I accept that. But
Yes.
it just for me though, even though you're explaining it from a from your like opinionated standpoint, this seems to be the standard thinking within the evolution paradigm, even among the scientific definition of it.
Exactly. But that's how science works. But then the question and this is what I said, you're getting what you ask for. So you're asking me to explain in context what I think. But then you can ask, then why do I think that the evolutionary paradigm is true? That should be your next question. And I would like to say that I can motivate why this is true. I have evidence to support that the paradigm of evolution is true.
Yeah, I've already. I'm sorry. Go ahead. I'm sorry. I shouldn't.
Yeah, and just so if you ask me that question, I can do that too. But it may be a bit late to do it today or whatever. But I would really like the chance to actually explain from the ground up exactly why I think it's true.
I was going to say I was there whenever you did it the first time.
And I appeared in a Nephilim hangout and tried to get my points across, and I was instantly swamped by pictures of mud piles and rocks and bent strata and whatever, and asked to explain that instead. So I never really got the chance to start from the ground up and explain why I think things are the way I think.
For me, that's not the problem. I have a distrust of the scientific community to begin with. And when I study historical literature and when I study scientific racism, I studied I just have a natural distrust basically.
Mm-hmm.
So for me, it wouldn't necessarily change my mindset.
Well, it would be fine with me if you also show the same level of distrust towards the creationist scientific organizations as you do with the established scientific community. Because it's fairly easy to show who has the actual evidence. And I can try to explain why you should actually trust what science or the mainstream scientific community does on the whole. Whereas the creationist organizations, what they are doing is not even science, and that it doesn't even make sense in the first place as science either. It never was science, and the way they are doing it
Well,
isn't science.
Okay, my rejection would be independent of creationists or anything of the such, basically. So I mean that wouldn't really change it for me. For me, science it established itself as the authority, then it perpetuates this ideology as if it's objective when it's not, and then it has this like propagandist mindset while proposing to be objective and open and free, basically, when to me it's not as objective as it pertains to be.
It's not objective on the level of individual people, and there are always disagreements. But as a collective effort, it is rather objective, I would say, because most scientists would actually like to disprove what other scientists say. I know the creationist story is that we all follow some kind of paradigm that we never question, but the way to get forward in science is to actually show that the other scientists are wrong. If you can actually do that, then you made it in science. So there is really an incentive to overthrow currently established paradigms.
There is. I mean, creationists have been saying forever that something along the lines. There's no such thing as, like Neff says all the time, mutations are there's no such thing as all mutations are deltours, basically.
That's what they're saying.
Okay, and now we've been saying that for years, and now what does the scientific literature say? I just read a paper that says synonymous mutations basically may be the cause for cancer, or let me just pull up the paper really quick.
Yeah, that's the paper you showed. Yeah, I was there in the post-hangout when you showed this paper. I know which one you're talking about.
But not only that, they're saying synonymous mutations the definition really doesn't match, because even though they don't alter the protein, they actually do. There's other things they do alter within the gene. So basically, they cannot be looked at as neutral. No longer looked at as neutral.
That is true.
The thing is, creationists have been saying, because just from the not that we had evidence, but just from a basic standpoint that we knew that you cannot randomly change something and have something beneficial, and that's from the creationist standpoint. So now the scientific literature is coming out years and years later, basically. But the creationists who've been saying this the whole time, I'm not sure if I'm sure there were some scientists who had to have known this, but I'm saying within that within the scientific community, this information, until they have, it just doesn't make it. It's just like filtered, basically.
So can I just ask, you just said we when you talked about creation. So do you put yourself in that camp?
Yeah, I mean that would be the camp I'm in.
Yeah, okay, it's just good to know. My argument would be right now, and you're getting this in context. Okay, I would like to step outside that present context and start from scratch, but you're getting an answer in the context, you're asking it right now. And then I would say these papers that you refer to haven't changed anything. The evolutionary camp has always said that some mutations are positive, some are negative, and maybe a huge majority would be neutral or negative. And very few would be positive in any given context. The whole evolutionary theory accepts this as a premise, and then the point is that selection would be able to sort out the few positive mutations among the negative ones. What you're doing is showing that maybe the number of neutral mutations are maybe not as big as we thought. And that it would place more mutations in the either positive or negative camp. That's what these papers are showing, that fewer mutations can be thought of as selectively neutral. Do you understand? That what the papers show is that selection has a way to act on these mutations that we didn't think was there before.
All right. Okay. So the scientific community is trying to figure out and understand genetics. Okay. So what you stated when you said the scientific premise of positive, negative, neutral, those are human constructs that we've applied and repudiated onto the research, basically. But I'm saying you're speaking as if it's some type of factual, empirical basis, basically. So now we're finding evidence that counteracts that, but all you're doing is trying to reinterpret it to match the created construct. You know, and that's what I just heard from what you just explained to me.
Well, yeah, that's the problem. I don't seem to be able to, and that's often the problem when I discuss with somebody from sort of your camp, that you're not hearing what I'm trying to convey.
No, I heard what you said, but
yes,
but I understand what you're saying. Basically, you basically said scientists have always looked at mutations as positive, negative, and neutral. And the information you've put forth is showing that the neutral mutations, as previously thought, not so many of them are neutral.
Yes.
But still, natural selection will filter out the positive and negative. And that I completely understand that.
Yeah.
But I don't think you understand how you're using this created construct to try to try to we're trying to figure out and understand genetics. But it's like you're I don't even know how to explain it.
Yeah, I understand. So where is my evidence that we actually do find this spectrum of different mutations, from positive to negative and so on, but at least with some positive mutations?
Well, and actually, I've read some papers that some from geneticists and biologists that said all mutations are actually deleterious, and actually it's some of them. Well, yes, because they reduce the fitness. But by nature, they reduce the fitness of the protein, or wherever their intended design is. They reduce the fitness of the cell.
Now I think you're taking what you have read and you're pushing it a little bit too. You're sort of running along with this a bit too far. But it would be easier if do show me an individual.
I don't have a paper.
No,
I don't have a paper, but I have a it's a profile page from a professor of biology. Of geneticists.
Mm-hmm.
Basically, and he states on his profile page.
Do you know his name?
Michael Lynch. Michael Lynch, basically.
Michael Lynch. Let me see if I can Google him then.
Actually, I think I can share a screenshot or something. But I just typed in his name and then he came up really pretty
Department of Biology, Indiana.
If you go to his facility page,
the Lynch Lab, is he at Indiana?
Yes, that's him.
Okay, let's see. Here we have the Lynch Lab. But and now we're actually communicating. You're showing actual sort of concrete. Do you notice the difference when, for example, when Nephilim is in a hangout, then it all becomes him ranting about sort of ascribing different degrees of incompetence and evil to evolutionists, etc., and the establishment and so on. But now we're actually focusing on concrete statement.
Yeah, but I think it's a two-way street, I think, and oftentimes some people just like to hear themselves speak, and I personally don't really like to hear myself speak because I'm not a very great speaker. But I'm more of a conceptual person. I can read and write very well, but I'm not so great at speaking sometimes. Mm-hmm. I can't formulate my thoughts. I might be able to understand something, but I can't put them in words. I relay them. But yeah, and it actually says most mutations are deleterious.
Yes. Now I see his research description. It says here, for example, our work on intron evolution is focused on the hypothesis that newly arisen introns are typically mildly deleterious. A major goal is to understand how introns eventually came to be integrated into fundamental aspects of gene transcript processing, etc. So he says that, but note the typically statement there that it's and I agree. In most cases, they probably would be or maybe neutral. I don't know.
Well, if you go down where it says the role of mutation.
Yes.
Evolution,
Okay. Yeah. Although mutations provide the ultimate material upon which natural selection depends, most mutations. But again, it's most. So I've never denied that most will be deleterious. So most mutations are deleterious and in certain settings can lead to a substantial fitness load. That is, you accumulate these mutations and it really gives you a problem eventually. We are attempting to understand the nearly 1,000-fold range of variation in the mutation rate that exists along the tree of life, etc., etc. So yes.
Yeah, you don't have to read it. Yeah.
Yeah, and I agree. Most mutations are probably deleterious, but it's also a question of, and the thing is that a mutation, whether it's considered deleterious or positive, is actually also context dependent. So it's always a net benefit to problems ratio here we have to look at. I think we may have discussed some cases, that are in a certain context positive for the organism, although it may carry some deleterious effects as well. Sorry, now somebody's washing dishes behind me. I'm gonna move, so we're not disturbed. Are you with me?
Yeah. Now I understand. Now, and here's the problem with so I know we're talking about mutations in general, but as far as if you go back to what is your definition of? Because I know last night we kind of got it. What is your definition of neutral mutations as it's understood in science, basically?
Okay, a neutral mutation from an evolutionary point of view or a selective point of view is a mutation that does not confer any kind of selective advantage or problem. That it doesn't change the probability that you will bring your sort of genes into the next generation.
Okay. All right. So as far as what two types of known mutations, or what types of known mutations are there that we can put in the category of either neutral or non-neutral, or what type of sub-mutations? I don't know how you want to phrase it. Because last night we talked about synonymous mutations.
Yes.
And from my understanding, that has been the typical definition of which the framework that neutral mutations worked under. But I know last night the other guy was trying to skate and put distance between the two.
Yes.
So I just want to.
Can I do, now? I disconnected my headphones. So do you hear some kind of feedback when you talk? Am I giving you feedback, or
there's no feedback?
Okay, things are okay. I just wanted to come. Well, so from the point of changing if you think that, for example, the functions of a protein depends on its amino acid content, or the sequence of amino acids that make up the protein, then a synonymous mutation would be neutral, because it does not, I mean, from the point of a protein, it's definitely still neutral, because it doesn't change the amino acid composition of the protein.
Exactly, and that's what I believe.
Yes.
That was my understanding.
Well,
but the other guy we were in.
Yes. Yeah, but then you can say, well, that is not all that. I mean, the way towards making the protein through the messenger RNA may be affected by the actual base substitution, and this is
as we've been reading.
Yes, and that's what. So then it is not selectively neutral, or may not be. There is a potential for selection going on there, definitely.
But then the question becomes, what is then? Basically, there is no mutual mutation. I mean, unless you can name me off another type of mutation, and that's what I'm asking.
Well, most of them could still be neutral. They just showed that in some cases they may not be. So we cannot just wildly extrapolate to all synonymous mutations. And there was also, I think, C presented a case, or he mentioned it. We never saw the paper, or at least I never picked up on any link to the actual paper.
I've got the paper.
Where the mutation actually affects the regulation of the expression of the gene.
Yes, because they have dual functions. They have more functions than we are actually aware of. Basically, just even their placement can actually affect. But here's a paper.
That's because we know that, I mean, making the gene is only one thing. So a lot of the differences between different organisms and how they are made is, of course, when and how much the genes are actually expressed. So two organisms may have identical genes, in principle, identical proteins, but the timing and the when they're expressed and the amount at which they're expressed will make huge differences for these organisms. So in that case, I mean, and this is also encoded in the DNA sequence, and mostly we have these called promoter sequences that are normally placed in front of proteins, but they can also be placed inside the genes as well that regulate how much the gene will be expressed. So and that would definitely change that as well.
Yeah, and I just wanted to have neutral mutations defined, because the paper I want to look at basically states that synonymous mutations can change mRNA splicing, mRNA stability, protein translation efficiency, and protein folding, basically. So in essence, if synonymous mutations can do all that, there really is not a mutual mutation, basically.
Well, they can do it.
It qualifies for the definition. But as far as
there's you show some examples where they do change things, but I would never say that an individual mutation, I would never bet on whether it's neutral or not. I mean, it's hard to know. Do you see what I mean? So what we know is that there are, in some cases they can have an effect, but I mean, I still think there are many places along the DNA chain where a mutation would do absolutely nothing whatsoever. But it would be, I wouldn't bet on any individual site, of course. I mean, something could always pop up. But yes, no. I mean, if we move, we can say there are no neutral mutations.
And basically, just go back to what I'm saying. Well, basically, what creationists have been saying is that mutations are overall they're deleterious. Basically, they result in a loss of information, a loss of function. This is the same thing that Neff says.
Yes.
You know.
Well,
I mean,
but you're too hooked up on information. I wouldn't necessarily say we do not speak of information. That's not a concept that biologists use normally. We do not equate information with function, because information is a property that is really, really hard to actually measure, and even to define. If an amino acid change, if a mutation changes the function or makes a gene into a pseudogene, have you actually lost any information then? And how much did you actually lose? Can you quantify this? That is not something that we really like to try to do.
If the sequence of amino acids fold to make a certain protein, basically, and you lose the nucleotide sequence, and you have a loss of information, and it results in the destabilization of that protein, then you have lost something.
No, I would say you have lost function, but not necessarily information. What you've done is you have two almost identical DNA sequences, and in one you have actually you have changed one base pair, so they only differ by one base pair. But I mean, I would say that they both have more or less the same information. They have the same number of bases, and you have just a difference in one base. So if you just look at the DNA sequence in isolation, it's hard to argue that any one of these would contain more information than the other. It's only when you try to read it out as in a functional context that you have lost function. And in biology, we don't measure the information content. There is simply no way of doing that. Does a rabbit contain more or less information than a human? Who knows?
We're talking about DNA.
Yes,
but I mean, you're telling me the genetic code is not information.
Well, not in a meaningful sense. We do not try to estimate changes in information. We do look at changes in function. So if you want to talk about functional changes, then I'm with you. That's what we can actually measure. And we can measure quantitatively how it affects the possibility to reproduce, for example. That is stuff that ecologists and evolutionary biologists work with all the time. But in most of those cases, we have no idea about the information content in the organism. And I wouldn't, it cannot even be quantified without specifying other things. You have to read, even the information content is dependent on context, I would say.
And I often do with with evolution. It's not specifically you, but once if I'm arguing for a specific point or trying to prove it's something, and then we finally get to that point, they usually say, "Well, that's what we've always said," and I'm like, "Then why have we been having this argument and discussion?" You know, I don't know.
Yeah.
But basically, we basically agree with each other. If you agree that most mutations are deleterious,
yes,
and then mutations will likely result in a destabilization of proteins, then yeah. I mean,
that part I would have to check whether it actually, destabilization is a very vague concept, so I would need to look into that. I'm not used to I don't work in biochemistry on a daily basis, so I don't normally think about these things. I think about I'm more from an ecological background, so I normally think about properties in terms of their fitness context in an ecological setting. So I would have to look into the thing about the destabilization. I don't work with protein thermodynamics.
Okay, I understand. And then now we've got this paper like I showed the other day, where not only previously thought neutral mutations, which were before they were neutral, they were thought to be beneficial, but then they realized there's no such thing as beneficial. Synonymous mutations frequently act as drivers mutations in human cancers, and the reason is kind of parallels with what you stated. It's because they're synonymous and silent mutations. They cannot be selectively. They cannot be effectively selected against. And that's why they. Yes, I mean, I've got the paper right here. If you want to look at it.
Say formulate yourself. Okay. Can you cite?
Because they're silent mutations, they cannot be effectively selected against.
Well, but if they have an effect on the fitness of the organism, they can be selected against. So,
yes, I know, and that's what I'm saying. Synonymous mutations don't alter. They don't change the protein, and basically saying because they don't do that, we usually thought they were good mutations, but at the same time, because they don't do that, they're not selected against effectively. They're not wiped. They're not the errors. They're bad mutations that are not effectively caught.
No, that is a contradictory statement, and this makes no sense from an evolutionary point of view. If they do have an effect, then they are by definition not selectively neutral, and then they can be selected against. Do you understand?
But it has to do with the definitions that we've added to it. Okay, here, let me just post the it only has the abstract to this particular paper basically, but I guess
I can probably look up the actual paper. Let me see.
It's called Synonymous Mutations Frequently Act as Driver Mutations in Human Cancers, and I'm basically saying the nature of a synonymous mutation prevents it from being selected against. That's all I'm saying. I'm saying the reason why they act as driver mutations in human cancers basically is because they're not caught, because they're silent mutations.
Well, but then they are not silent. They may be silent from.
And then that has to do with the scientific community's labeling and definition, basically. Well, that has to do with them. But I'm just basically stating that you're right. It's contradictory in itself, but that has to do with the naming and labeling.
Yeah, but evolution doesn't care how we label things. It will affect actual effects, sort of. It will work on really whether these things does affect, if these things do affect fitness or not. That is the only thing evolution cares about.
Yeah,
but what I suggested, that maybe it's a bit more subtle. It may be harder for evolution to pick it up. But I mean, this is sort of the more neutral a trait is, the less effectively it can be selected against, or for that matter. Do you understand? So the less effect it has on the fitness of the organism.
I completely understand the definition, but the thing is, what they previously labeled is not. It's not the issue. Is not with my understanding. It's what was previously labeled as synonymous mutations or thought to be synonymous is actually not as synonymous as we previously thought, and now we are figuring out the consequences and effects of those, and some of those consequences and effects of those are actually deleterious. If the information says they're deleterious, then it's deleterious regardless if it's labeled as synonymous mutation. It doesn't change the effects we're finding, and all I'm stating is the paper has found that these previously thought neutral synonymous mutations, because the reason we labeled them synonymous is that they didn't change the protein, is the reason why they're not selected against. But in essence, they actually aren't. They actually aren't synonymous as we thought, basically.
Sorry, they are still synonymous, but they are not as selectively neutral as we thought. I would like to reformulate what you're saying. They are still synonymous.
Yeah, that's fair. That's fair.
Yeah, the definition of synonymous stays the same, but we find that they have more ways of affecting the organisms than just changing the amino acid sequence. And here you have because a lot of RNA is actually regulating itself. And in that sense, definitely you could affect the expression of genes through changing the RNA sequence, and that in itself comes from the DNA sequence. So any kind of mutation in that context could have an effect on the organism, definitely.
Yes, and then the question becomes, then what is neutral? I mean, we have a definition for neutral, but the thing is, there may not be any neutral mutations that actually exist.
Well, I think there are still neutral mutations. There are definitely anything that goes on.
I get what you're saying, but as far as the evidence I'm looking at shows what they previously thought was neutral wasn't neutral. So I don't really see there's two. I mean, you can make the assumption, but I just don't see it. But I understand what you're saying.
Yeah, what you're seeing.
I'm basically saying that the neutral is basically useless.
Yeah.
Because we don't actually have a mutation we can actually look at and say this is the neutral one we're speaking of.
I mean, it's eventually you would have to measure it somehow. What we would normally do is to see how it actually affects. We would study a certain genotype and see how it's actually doing in reality in some kind of context over several generations, and see if it's having a problem. Sorry?
I'm sorry, I learned to stop interrupting you, but I actually was reading a paper that actually was very discussing the fact as far as they need to reclassify as far as what they mean by synonymous or neutral mutations, basically. Hopefully I can try to find that base, because it was actually pretty good. It was just talking about the present paradox, So, but the thing is, and this is the stuff that when I speak with people, because I mean I'm not very versed, I'm not like a biologist, and I can't enunciate it as well. But I know what I'm talking about. And the thing is, when I read these scientific papers, and this is like echoes what I was saying in the other chat. This is what the actual scientists are actually studying on and trying to figure out. So when I sell this stuff to evolutionists, they act like I'm crazy or something, and I'm like,
no, you're not crazy.
Like Michael Lynch, this is what he's trying to figure out. This is what they have theories for. The nearly neutral theory, molecular theory of evolution, basically. This is what they're trying to figure out. So, and that's all it was. That's basically all I was asking. I was making those statements, which are true, that most mutations are deleterious, and I believe that mutations, most mutations or all mutations, will destabilize a protein if they, the proteins basically. So
yeah, I would still like to see what you have shown are still examples, and I would still like to see a full spectrum, because this could probably be measured in some sense. So to actually look at the distribution from positive to neutral to deleterious, it would take a lot more effort than that. What you're seeing is usually in a medical context as well. You're seeing things where they try to motivate their research in a medical context. These are not evolutionary biology journals, for example, where we would normally talk about sort of how to understand things from an evolutionary context. What you're seeing are things, people trying to motivate things from a medical point of view, and you are seeing a somewhat skewed image where they're referring to cancers and disease and problems all the time. But that is because that's their way of in the introduction or whatever, trying to motivate their research. So they're always talking about the deleterious effects in these journals, because that's their way of simply motivating. Why did we do this? What they're focusing on problems for people. So I think you have to be a bit careful with sort of in what context you're reading this. We could probably find examples that would show more neutral effects if we were sort of looking at it from other sources.
I mean, like I said, I'm not a scientist, but I've got I've got quite a bit of papers on my computer. I haven't read them all, but I mean, just on the degradation of the, or just on synonymous different various types of mutations. I think I've got like 10 or 11 papers, and it's not actual. They're not. These are from different journals, basically.
Yes.
They're not. It's not like one journal, but I mean, a lot of them are. They're on PubMed.gov. I mean, yeah, they've got. It acts like as a browser where you can pull.
I know.
All these different papers from different journals, but I mean, it's different journals. Some are medical, some are science, some are genetic journals. But yeah, so I get what you're saying, but I mean, I think there's a cumulative amount of information that is basically starting to set the precedence. I mean, that most mutations are deleterious. So,
and I've said that from the beginning. Yes, they would be, but that is more or less what we would expect. Do you remember what I said about that organisms are expected to be more or less adapted to the circumstances as they're in right now? And that would mean that any shift away from that would actually be deleterious. They would be expected to be at a local optimum. So I'm not surprised that most of the changes you see would actually be deleterious.
See, and I understand what you're saying, but to me, it goes back to it's like the retroactive reasoning, it's like reasoning retroactively to explain it to fit in within the paradigm of evolution. And I don't see how you can honestly believe that you're being objective when you do that. And it is not you though. It's the formulative way of thinking. This is the paradigm of which this science functions within, basically.
Yeah.
I mean, and that's my issue with it. It's a continue. And the thing is, I've read into other, like when I study ancient or historical literature, when I study racist pseudoscience, how these scientists believe, they have real papers, like thousands of papers basically, about how Africans were subhuman, just below and just above animals and just below humans that function within a paradigm.
And they were retroactively trying to find things like skull shape, etc., to motivate how to classify people. Mm-hmm.
Yeah, they filtered the evidence based on their assumptions, basically.
Yes.
And for me, that's why I feel like I see within this evolutionary paradigm. And that's where my distrust comes from. It's not that I reject science. I actually love science. There's certain sciences I actually love, but I mean, it's that thinking. And then when I speak with atheists, their hatred and vitriol and their intellectual dishonesty, like that's what gets me. But you're right. There's a lot of that's on the Christian side. I don't really try to play it. I'm more of a spiritual person. I mean, a lot of people you speak with on Google Hangouts. I mean, because the Bible talks about humbleness, humility, kindness, meekness, basically, and that's the values of Christ, being Christ. Unfortunately, a lot of people don't exhibit those values. It seems like people like to hear themselves talk, but they just want to prove you wrong, or someone. I actually would like to, I like to put my knowledge to the test, basically.
Yeah.
And to try to increase my knowledge. But this is the thing. This is this kind of type of stuff I run into.
Yeah, I must warn you, when you talk about spirituality, I'm a hardcore materialist from to the core. But anyway, I like values like ethics and love and all these things you mentioned. I just want to explain them from a materialist point of view. Anyhow, but I get what you mean. I was wondering, is Scorepio, are you still there? Just checking. Is it just?
Yeah, I'm just listening.
Oh, okay. Just so we don't, so we're not losing anybody. And I hope you enjoy the conversation. You haven't said much, but maybe sometimes it's good just to listen.
Well, yeah, that's the thing. Is you and I were talking, and Tetra there, he held his peace, and okay, so I'm just I'm being polite in the conversation. I'm you guys are discussing specific points. I don't want to step on anybody's toes, and I don't want to shift the conversation to trying to answer a different argument or a different point. so I'm just letting you two talk.
Yeah, just
No,
as
you're
long.
fine, man. I'm probably about to get out of here. It's about to be 3 o'clock where I am in the morning.
It's 4 a.m. here. I'm starting to get tired myself. So
We should maybe finish here before somebody sort of just passes out. But I think it's more useful to have this kind of conversation than having like 10 people screaming at each other, with some people in the sort of simply trying to disrupt the conversation. And I acknowledge all your points, Tetra, and I would answer them by moving several steps backwards and starting from an even more basal position in my argumentation. But as you said, not right now. Not right now. But yeah, I don't know if I try to set something up for next Saturday or something. If I start in the morning and you start in the evening, if you look at Google Plus, you will see my conversation. It should be possible to set something up, and then I could start to present my understanding from the bottom up of how these things work.
All right. I mean, well, but I really wasn't into. I mean, whenever you were given the whole paradigm thing, like I really wasn't into that. The whole spiel from, yeah, it's
So you
well,
don't.
I mean, I'm more than willing to listen to your explanation. I did hear. I was listening to that particular chat when you were in with Neff and the rest of them, and you know, I realized you didn't get a chance to go through the whole thing, but you know, I understand the position that you're coming from, and the, you know, the mainstream, you know, the elements of the mainstream points that you covered.
Yeah, and the thing is, I'm not referring to mainstream as an argument here. I happen to agree with the mainstream simply because I do think I understand the evidence. I really do think I do, and I can present them in a way that would make it really hard to refute, actually. So I'm not. It's not an argument from authority here. I think it's easy to look at the individual pieces of evidence and put them in a context that would really forward one side in an argument. But that is my. I haven't actually put that to the test yet to you guys. Over to you.
Yeah, no, I just, I mean, I'm open to whatever, but I already feel like half these conversations we listen to on Google Hangouts are so long and so unnecessarily drawn out and so repetitive, you know. So I like I told you, I work 60 hours a week. I mean, I was off this weekend because of the holiday, so I mean, I haven't been on Hangouts as much as I can, but you know, it's I like to cover a vast amount of issues and topics basically in a little time. Like just like today, we had I think Neff was discussing something with somebody. I think they were for 2 hours and going back and forth, just basically saying the same stuff over and over again.
Yeah, but the thing is, in science, you have to. It's the details that matter. You really have to. You should never move on to the next point until you've actually nailed down the first, because science is all about putting everything in a context, and if you disagree on the basal context, you should never move on to the next level. And this is the problem that you see in these discussions, people running back and forth from one case to another without actually putting it into a framework where you can understand that to test the hypothesis and actually choose one alternative over the other, and actually everybody can agree, yes, the evidence favors this interpretation instead of the other one. This is what science is all about. There is no shortcut.
And that just goes back to what I was saying earlier. I don't believe modern science, as far as in the evolutionary sense, is objective to begin with.
Well, there is an objective aspect that it's all grounded in data. unless you assume that the data is fabricated, we have an objective sort of way to, we can ground our reasoning in objective data. And if you're going to say that the data are fabricated, I'm going to bet against you. So in any case where you say this is probably fabricated, I can take my daughter's college fund and put against any kind of financial resources you have, so we can actually go out and test what the real facts are. We can set up we can go out and look and see what the facts are. We can see what the data are really like. And that is a challenge I would put to anybody I discuss with. If you want to really say that the data are not what they are, let's go out and test it. And I'm going to bet that against you or anybody else. I will bet against you. I will put my money on the line and you put yours, and we'll see who is right. The loser pays the cost of this investigation.
Yeah, but that's the thing. You can't test millions of missing transitional skeletons. You can't test millions of years. I mean, you can calibrate them. You can have different forms of dating them, but you really can't do empirical tests. You can't say 100%. I mean, I don't even think the tests they don't even use 100% certainty on them. But the 100% certainty that
there is no such thing. Everything has uncertainties, but that is part of the method. If I would give you a piece of string, okay, or we take the same piece of string and we give it to 10 different people, and we give them a measuring tape and say how long is this string, we would get 10 different answers.
Yeah, I understand that, but it's the nature of it when you're basically saying something's 10. That's different as far as estimating a percentage of a string than when you're using an inference of something being tens of billions of years old, basically, to fit within the paradigm.
It is not it is not difference. All measures come with some kind of uncertainty, and we can take that into account in any kind of scientific model. What we're testing is whether the trend we're seeing is actually stronger than the individual uncertainties. And if we continue this discussion at some other time, I can explain to you exactly where we look at the uncertainties and how we go around that. You can measure the same when you're talking about measuring millions of years. We can approach the same question with 3 different methods, and if they all agree within the limit of uncertainty, we have 3 independent ways of measuring that these things are correct.
Yeah, because they're only correct if they're calibrated to match the paradigm.
No, that's where you're wrong. And we have to look into certain. So now you're talking creationist speak. And I'm sorry to say that, but now you're wrong. You're simply wrong. But I would need to show you some concrete examples to explain to you why you're wrong. It's meaningless to discuss things as generalities, because these methods are actually independent and by themselves rather objective. So you would have to challenge them.
Sorry? You're talking about radio 3 independent radiometric dating.
For example.
Techniques, right?
And not only, you can combine that with other things as well. You don't need to, depending on the time frame, you can have other methods as well. So that's what I wanted to that's why the examples of the valves is so incredibly pedagogical, because it really uses many independent ways of looking at the same sediment core, and you actually get the same answer from 3 independent methods. 2 of them are related to radiometric dating. The other one is basically a way of estimating how many of these valves you have, and these 3 methods all agree. So it's really hard to claim that this is not a fact. But I would have to show you a specific example, just like you are showing me papers now where they're stating certain things. We would need to look into an individual case or many individual cases, and I would have to explain exactly why I think this is really strong evidence and why this is not paradigm bound.
Yeah, and it's not that I don't think there's not any functionality to the dating, but when you get past a certain time frame, whether it's 10,000 or 100,000 years, I mean, you're extrapolating those dates, and you have to assume that assume certain conditions are constant to get those numbers, basically, especially when you start talking about billions and billions of years. And how do you account for atmospheric changes, basically, or different or elemental changes? I mean, that's the part I just can't comprehend.
If you have two completely different isotopic systems showing the same thing, it's not up to me to show that this is sort of correct. It's up to you to disprove or to show why these two independent systems. I mean, what physical thing could actually make these two independent systems show the same thing? Do you understand? I mean, it's up to the creationists to actually demonstrate scientifically that there is a process that can cause this observed result, and they don't do that. They are just saying, it's all assumptions. It's not all assumptions. These are very well grounded results, and they are really easy to understand from everything we know about physics and science in general. But the creationists try to simply disregard them, and they sort of mumble something about assumptions, which is just nonsense.
Well, whenever they reevaluate the age of the Earth and move it by billions or 500 million years, basically, I mean, I think that gives someone ground to doubt their techniques, basically.
How often have they done that? When did they ever change these by 500,000 years? The age of the Earth. When did that happen?
I'd have to pull up. There was I think it had to do with the geologic time scale.
I mean, the geologic time in the times of James Hutton or whatever, a person who came up during the previous post-hangout. I mean, they would basically probably finding evidence that, well, things have been going on for a hell of a long time. That's how precise they could be, and they could probably order these geological systems in a certain chronological relative order. They knew that the Ordovicium came after the Cambrium, because you always find Ordovician layers on top of Cambrian layers. So they had a relative order of things. But I doubt that they could put very precise measurements, as in times of millions of years, on these systems. So, I mean, and when the radiometric dating came, they could, I think, for the first time really put objective values. And since that time, I don't think the time frames have changed very much. You tend to find exactly the same overall time frames wherever you look on the Earth, which by itself is a very strong indication that the original assumption was correct. Now, the only way for you to actually question that would be to question that I mean, some creationists say that scientists only pick the dates that suit them, and this is just wrong. And then I would, it could be easily disproved, and that's my point. If the creationists really wanted to disprove the mainstream geologic timescale, they could do so easily. And I know that you will try to cite papers from creationists that seem to do just that, and we can look into them, and I can try to explain exactly where they are wrong.
No,
am I getting too preachy?
No, it's just it's 4th of July, so
yeah.
Okay. Get everybody and go out tomorrow.
Yeah,
and
yeah. So we should probably finish here, but it's more productive to speak on, well, a few people where you give the other person really time to speak, as we do now, than having a big shouting match with 10 people involved.
Well, that's true, but some people that you just can't have certain type of discussions with. They're not there to have a discussion. They're not really there to engage in.
But then do like evolution does. Select the ones that matter. Yeah. I mean, focus on those. And as we say, if we do hangouts and these things, the good thing is that this is no longer just a conversation between these people. It will be available on the internet for other people to to sort of start where this discussion finishes off, and then one can continue the discussion from there. You don't always have to start from square one.
Yeah, this one wasn't live though, unless you recorded it. It's
I did record this. I don't know how I'm gonna, if I can put it up. I don't know what the rules are. You can publish Hangouts, but I don't know how you can do if YouTube allows you to put things online, unless it's several hours of video, unless it's a Hangout. So I don't know how these things work. Maybe somebody can tell me. But the information will be there.
Yeah, I think there's a limit. I think you can only do 30 minutes.
Okay.
I believe. I could be mistaken.
But I think
you have to.
Yeah, if we just edit out the general conspiracy theories and stuff, it should boil down to a few well-partitioned pieces.
Yeah. Well, you can do longer, but I think you have to go through some type of verification process or something.
Okay.
But all right, man. It was nice talking with you.
Yeah. Likewise.
Want to get out of here.
I really enjoyed the conversation.
Yeah,
me too.
I'm just about out of it myself. So.
Okay. Good night then,
you
folks.
guys have a good day. Already,
Yep. And happy
almost
4th.
sunrise. So.
Yeah, happy 4th.
Yep.
You too.
Well, I'm Canadian, so my Canada Day was already passed. So.
And I'm Swedish. We already had our national day, but yeah. Have a good one, Tetra.
Yep. Okie dokie. Bye bye.
Bye.